Assalamu alaikum. This is a quick tutorial on how to use the app which I have uploaded recently in GitHub. The app solves the time-independent Schrodinger equation for infinite potential well. We just need to upload a photo of this potential and it will output the probability density function. And we can also select the energy range. So if we can select to to solve the Schrodinger equation from the ground state to the 100th excited state, and so on. So I left the link in the description. You can go ahead and download the file from the Google Drive inside the GitHub page. You will need to download this full file. I have the file, so I'm not going to download it again. So this is how the file looks from the inside. Each photo each photo is for a specific potential well. So the black region is the region where the potential is 0, and the white region is where the potential is infinite. You can go ahead and run the app without changing anything. At the beginning, it will solve the Schrodinger equation for this potential. So we can try and run the app. So this will take some time depending on your PC, and also depending on the resolution of the output. The resolution of the output depends on the photo that we use initially. So if we use 100 by 100, I mean 100 pixels by 100 pixels, that's the resolution of the output. So you can start by like a 30 by 30 or 50 by 50 or something like that. If you start by 100 by 100, it will take a very long time. So as you can see, after running the file, it will save all of the solutions as PDF in the same file as the application. So now it saved 10 PDFs, and each PDF is for a specific energy state. So this is the ground state, for example, and you can change the energy range from energy range.txt. So inside this txt file, you can write from where do you want it to start. So this is the energy range. Here it's from the ground state to the 10th excited state. You can change this, for example, from the 5th to the 100th excited state. And the one after this is if you want the application to save the eigenvectors and eigenvalues as a NumPy array. You can use one if you wanted to save the results as a NumPy array. It will save them in the same file again. If you don't want to save them, you can change it to 0. And also, if you want the application to solve the time-independent Schrodinger equation for a different potential, you can change that from the other txt file, from imagename.txt. So what you can just copy the name. You need firstly to paste the photo in the same file as this application, and then you can paste the name of this photo here. You can delete this one, and you can paste the name of the photo that you want here with the extension. So if it's like .gbg, you need to include the extension as well. So one thing to note is that when you run the application, all of the graphs will pop up. So you need to, if you just close all of the windows and close the application, it will save all of the PDF files, but it's not going to save the eigenvectors and eigenvalues. So what you need to do is you need to close all of the graphs, but not the application. So after closing the graphs, it will save the NumPy arrays and then it will close automatically. And so to show you, like as an example, I plotted a very high resolution graphs. This is for the butterfly potential, and as you can see, I plotted around 3,000 plots. This is the ground state, and you can play around and try it for different potentials. So as you can also see, I'm using a relatively low resolution photos. So if I want a very high resolution output, I need to use like a higher resolution photos. The resolution of the output is the same as the resolution of the input photo. But if you use a very high resolution photo at the beginning, it will take a very, very long time. So if you have like a good PC, you can try 100 by 100 or 150 by 150. I will also leave a link in the description to this website. You can use this website to resize the image that you want. So if the image has high resolution initially, you can use this website. You can upload the image here and then change the dimensions of the image here and then click resize, and then you can download the image from here. Then you can just paste it and in the same file as the application, and then paste the name of this photo inside the txt file as I mentioned before. My friend Esah has also contributed in writing this code. I will leave his full name in the description. And that was it. Thank you for watching.